Okay, this is a short video about recording what I learned recently, which is the dynamic programming. So let's talk about that. Suppose we have a sequence of y values as a function of time. It does not need to be function of time, but for this example, let's say we have this type of pattern data. So three similar value and suddenly change and change, something like this. Again, it doesn't need to be a time series, but what we want to, so this is the y is the sequence of n values, but it can be vectors, like embeddings of the sentences or word or any vectors like EG data. And what we want to do is we want to segment to units. So similar ones, like in this case, these three and the next six and next four, two, one, three, and one, something like that. So how can we chunk this sequence into group of similar values? Okay, in unit here it means group of similar neighboring values. Adjust the values. So k means will not work. K means we'll handle this y as a bag of values without any order, but this is a sequence. So using there are many different ways, but in this video I will talk about dynamic programming using BIC specifically. So first, the first step, define cost functions. Of all possible units. So we can define unit as a range start to end, right? Start to end any index, and we will follow the Python convention here in this example. So which means from 2 to 5 means does not include the 5, the end. Okay? And we can define cost. So here, for example, there can be many different types of cost functions, but here we will use SSE, the sum of the squared error. So which means when you have three values in the unit, we can define the error. So this line is the y of the three values. So SSE, if I remember correctly, squared error and its sum. So in terms of pseudocode, we can define unit cost as a dictionary of each unit. Two numbers, start, end. and it's a key. Let me clarify. This is a key. This is a key, and it's defined the cost of that unit. Right? And then for all possible start in range n-1, because it should be start, for all possible end for the given start, plus 1n. Yeah, let me remind myself quickly. So in this case, let me write it down first. Y part, the piece will be Y start to end, and unit cost will become SSA, this Y part. And yeah, I used MATLAB for more than 2 decades, so it's always confusing to me. So let's double check. So first loop, start and end, if without plus 1 it will be 0 and 0, so this will return empty, so we should not do that. The first loop should be 1 to 0, it will have only 0, so the first unit that contains only single value, right? So that's why we need plus 1. And we can check last loop. If we don't have this minus 1 and the last n, so if n, start n is the n, range n, this is empty, so not good. n plus 1, n plus 1, then it will return n, but n is the outside the range, because the last element, last is n minus 1, so it should be start and end should be like this. Right? This is correct. So this is the last index of y. So this is the last unit that contains only last value. Okay, so we can make this list of dictionary. So we can build unit. So this will be done. Wait, this will be a dictionary, right? And then second step, we will fill minimum cost matrix. So I will explain what this is. So this is very important. Minimum cost is the matrix. So basically square matrix. Here is a B matrix, right? And the row is the let's say I from 0, 1 to n. We have n values, and j is from 0, 1, 2, and minus 1, and n. So this is the basically n plus 1 times n plus 1 matrix. And I means first I values. J means J units. So mean cost is defined by each element is the minimum cost of segmenting the first I values. So we take the only first I values out of the whole sequence and segment this into J units. Okay? And then we can calculate the cost for many different combinations, and we can choose the minimum cost with the combination. And so we can find quickly. And we will define another K, but it's a little bit complicated. Let's quickly see this minimum cost a little bit more. So easily we can see I equals 0 and j equals 0, and when I is smaller than j, all these cases are nonsense, because we cannot segment or split 10 values into 11 units, right? Something like that. So the default value of the cost is the infinite, and we can see all these I equals 0, j equals 0, and then all the other areas. This, they are nonsense, right? And also we can easily know when I equals j is the all units have a single value per unit. So this is the SSE equals 0. The sum of the all SSE for all units, the sum of SSE, which is the cost function, equals 0. So this will give you 0, 0, 0, 0, 0, 0 here. Okay? So diagonal will become 0. Or we can set as infinite. We can leave it as infinite if we want. I think it doesn't matter. And now we will calculate the j equal 1 first, because j equals 0 is the we already know, which means that only single unit, right? So only single unit. In other words, segmenting I values to only single unit. So it's not segmenting. So we can set, so the cost function, cost will be the SSE of that single unit. So we can write down 4i minimum cost, unit cost, zero and I. Yeah? Because a single unit contains from 0 to I values. So I values. And we need n plus 1 because max I should be n. And now let's talk about when j equal larger than 1. But for easier understand, let's think about j equal 2. It's the same logic, but 1 by 1. So it means that segment I values into 2 units. So it means that we have I values. So y and I 0, 1, the index. The last one is the I minus 1. The index. This can be confusing. So this is part of the whole sequence. So number of lengths of the y, so I. And then we want to segment this into 2 units. And now we can introduce k. It means that we can segment, let's say here, so 2 sequences, and let's say here is k. So from 0, k minus 1, right? And then from k, I minus 1. So this is the splitting point. And we can define k as the end point of j minus 1 unit. So it means that all the this is a j equal 2, so you have only 1 unit before the k. But in general case, when j is larger than 2, is the end point of the all the units other than the last unit, right? And y means that length of let me clarify total length of j minus 1 unit. In this case, a single unit, the previous unit. And we can define here optimal k as a dictionary of I and j. So this means that optimum the k value minimizing the cost of segmenting the first I values into j units. So we don't know the answer yet. But assuming we found the minimum cost of I and j, there should be a k that resulted in that minimum cost. So we have some pair minimum cost I and j happens at optimal k. So it's like an argument minimum. There's a pair. So they are corresponding to each other. So let's think about in this j equal 2 specific case, then we can make a code. So the logic is when we have I minus 1 length of y and we want to find the k, right? Then what we can do is that for give me a pseudocode for k in range of k can be k cannot be 0, right? Right? K should be 1, the minimum. So here's the k, the minimum k, and maximum k is here. So this is a minimum k, this is a maximum k. So this is from 1 to I minus 1. Okay. So that's the k range. And for this range, we can calculate u cost as the SSE of the first unit plus SSE second unit, right? That's the cost for given total cost. Let me this is total cost for a given k. Okay? However, the trick is, in general case, if the first part has the j minus 1 unit, if this was j minus 1 unit, not a single unit in general, and j equal to 2, this is actually the minimum cost of splitting k values, the first k values, into j minus 1. Okay? This is the core concept of dynamic programming here. So we can replace this plus SSE, the unit cost. We found the unit cost above. We calculated all unit cost from k, the second unit, right? K from k to I. And if the new cost, we will repeat this for every k, so we can update the minimum cost, the total cost, which is ij, right? Because we are splitting first I values into j, we can update to new cost, and we also have to update optimal k. Because this specific k results in the lower value. I hope it makes sense. So in general, when j is larger than 1, including 2, we can write down for j in range from 2 to n, so n plus 1, and for I, so for a given unit number j, so unit number j is fixed now, then we can repeat, because we want to fill out this matrix, right? So we just filled out the first row when I equal 1. This is easy. And then we take a good look at how we can fill out this second I equal j, the third column, where is j equal 2. And we can repeat the same logic for the others. So for I should be in range from j. So it means that, okay, segment the first I values into j units. And for this, we can investigate all possible k from j minus 1, as we discussed above. And this means we need to segment the first k values into j minus 1 units, because k was defined by the length of j minus 1 units, and actually this was done in the previous loop of this code, because j minus 1 was the above. It means that we already filled the column, or in other words, the previous column of because the matrix was already filled, right? So we can apply the same. So if we can find new cost, is the min cost splitting k values into j minus 1. And again, this is the previous column, right? j minus 1 column plus the last I. This is the last unit. And this is the j minus 1 unit. So we can do the same update if this new cost smaller than the value we wanna update. Okay, here we can change. Actually, this is a matrix. Cost I j to be accurate. Yeah, optimal k can be also matrix if you want, or it can be a dictionary. It doesn't matter. So this is the again matrix. This is previous column. So then minimum cost will be updated. And optimal k will be k. So we filled out all the values. So I equal 0, 1, n, and j equal 0, 1, n. And again, the first column, first row, nonsense. And this as well, the upper triangle, nonsense. So we filled out, and this is all 0. And we filled out the other ones, right? We filled out the column by column. So this again, j, the first I values into j units. And using this, we can segment to a given, so if say given n number of segment, then it means that we can start with the this specific n seg, let's say, and then we can find start from minimum cost of n values into n segment, which is this. And then for this, we already know this minimum cost and corresponding optimal k Or is confused. So this is the optimal length of j-1 units. Actually, n sigma minus 1. So we can move on. The previous column, J, like this. With K. So it means that mean cost, so we accept the last, which means that we accept the last unit of, let me see, K was the n minus K values, last values, right? And then we will segment the other part, the earlier parts of the into j minus 1 or n segment minus 1 unit. So this is, we move on minimum segment cost K and n segment 1. So we have to segment the first K values into n segment minus 1 unit. So we are jumping to this and jumping to this. So we repeat this until we reach the first unit. And then first unit, it may have a single value, two values, or many values. So in terms of pseudocode, what we can do is the first start with the I equal n, n equal n segment, and while repeat, take a K for the current I and j, and then we have unit indexes and append. Okay, we have a unit indexes here, empty list, and range from K to I, right? So it's the last unit we accepted, just accepted, and then we can set the number of segment on down and the length of values first resolution. Okay, so we can repeat that until when j is larger than 1, and maybe we don't need to separate, but when j is 1, we can append the last, right? So the first unit, maybe this can be included in the while loop, but either should work. So in this way, we can segment into n segment. And if you don't know what's the optimum segment, then you can try collect SSE. This first step can depend on your cost function, but in this cost function, let me clarify that. Cost function is SSE, but for the other cost function, we can develop something similar strategy. Collect SSE of unit for each and cell candidate, and then calculate BIC, YIC, and find and segment to minimize as argument minimum, and BIC is the adjust the bias of n segment. So when n segment is larger, I think the SSE is supposed to be lower, because so when n segment is larger, then total SSE is smaller, because when you have a larger segment, individual value number for each unit will be lower, so SSE can be lower, right? So, but the BIC will compensate for this trend. And how to calculate the BIC from SSE values? I mean, we can find it online. Okay, this is it. I think this is very useful to play with any type of sequential data, even easy data or whatever, multidimensional time series data, when we want chunk the time series data into a series of the similar units, right? And I am making this to handle the large text data. So I wanna chunk long text into semantically similar into units of semantically similar sentences using embeddings of each sentence, where embeddings is the vector representation of each sentence.